Today we're doing section 2.2, day 2, and we're going to be talking about graphing quadratics when we are in standard form. So a little recall, standard form of a quadratic function looks like so. So 8x squared plus bx plus c. So notice there's no quantity squared. That's kind of your main difference. So again, a is positive versus a is negative. We'll still determine how the parabola opens. The x-intercepts you still set equal to 0. So for my x-intercepts, I'm still writing f of x equals 0. For my y-intercept, you're going to find f of 0. The only thing that's going to be really different is finding the vertex. So to find the vertex, we do this calculation of x equals negative b over 2a. And once I have that value, I'm going to plug it in. So essentially the vertex will look like this. The x part will be negative b over 2a. Whoop, dropped my pen, sorry. And the y part of the vertex will be when you plug in this negative b over 2a value. So whatever you would get from that, you plug in, and that represents the y part of the vertex. So let's go ahead and apply this to a problem. So because my a value is negative 1, my parabola is going to be opening down. Let's find the x part of our vertex. So I have negative of a negative 2, so negative b over 2a. So I'll have 2 over a negative 2. So the x part of our vertex is negative 1. So we know that much. Now we've got to plug that in to find the y part. So I have negative of a negative 1 squared minus 2 times negative 1 plus 1. Excuse me. So a negative 1 squared is positive 1, but there's still that negative 1 out front. This will change to be plus 2 plus 1, so I'll have 3 minus 1, which will be 2. So the vertex is at negative 1 and a positive 2. Y-intercept is just I plug in 0. So if I plug in 0, I'm going to get positive 1. So there's really no work required when you're in standard form. The y-intercept is always your c value. And then lastly, I need to find the x-intercepts, and that's when we set it equal to 0. This one will not be factorable, so if I do a times c, I get negative 1. And nothing's going to multiply to be negative 1 and add to be a negative 2, so we're going to have to do quadratic formula. So I'll have negative b, so negative of a negative 2, plus or minus the square root of b squared minus 4 times a times c, all over 2 times my a value. So just for the sake of space, I'm going to take that square root part over here. So underneath the square root, I have negative 2 squared, which would be 4. Then I have negative 4 times negative 1 times 1, so that'll be plus 4. So we're dealing with the square root of 8 underneath the square root. That can break down to be 2 root 2 because 4 and 2 multiply to be 8. So now I'll take it back over here. I have positive 2 plus or minus 2 square root 2 all over negative 2. So I can reduce everything by a negative 2. So I'll get negative 1, and we just switch the signs. You say minus plus, really not a big deal. You could keep it plus or minus if you'd rather, and you still have the square root of 2. So because we need to do this on the graph, you'd actually figure out what the square root of 2 is, and then you would do negative 1 plus or minus that decimal. So when you do that, you get 0.414, and we get negative 2.414. So you do have to find them as decimals, so that way I can get these two x-intercepts on my graph. Alright, so the vertex we determined was at negative 1, positive 2, so that will be right here. My y-intercept is 1. So again, because this is my axis of symmetry, I can reflect that point, so I know the point 2, 1 is going to be on the graph. And then negative 2.4 would be about here, would be a little bit under halfway, and then 0.4 again would be a little bit under halfway. And that's enough to go ahead and create the picture, you're just in standard form. So same kind of concept. Some of the steps are a little different just on how you approach them, but overall, this should be a review of Algebra 2 material. That's all for today.